And I started this one already just based off what I saw in class. So I can send that to you too.
So are you guys doing amount, percent, and total?
I don't think we're doing percent. Here, I have notes. If I pull those up. In it's kind of like here we go.
So we're making such a big deal out of this, and this is not a very complicated problem. I wanted to
Yeah,
kind of also get you to see like we're really kind of overdoing it. But having said all that, you got to do it.
yeah. I can't find the notes online, but it's just kind of like the value. I think is one of them. The
It's not always percentage. In this case, percentage is really the money. It's the money times the amount plus the money times the amount
yeah.
equals, in this case, the money times the amount. It's usually percentage. It is a mixture of money, but it's not a percentage.
Hmm.
Um, and so we're kind of overcomplicating this. It's it's 150 times however many X tiles you use plus $9 for every Y tiles you use, and you want it to be an average of $3, and you need 1,000 tiles.
Hmm.
Now, let me throw some things in here. Like you might be doing it this way, where this 1,000 is X plus Y because it is. Um, and Y, if we're gonna change Y to being 1,000 minus X because you don't want two variables. You only want one variable in your problem because it's this way. However many X you're using 1,000 minus X. If X is 400, you're
Yeah.
using 600, and it's 3 times 1,000 because that's how many square feet of tile. And so somehow you're going to create a table that you get 1.5x, 9 times 1,000 minus x, 3 times 1,000. And notice that there's one variable in this equation,
Hmm.
which is good because that's what you're solving right now, is equations in one variable. Okay. Now
Yeah.
we could solve this, or we could just say, you know what, we're good. I know how to solve these and move on to another problem, or we solve it right now. What would you like to do?
Um, if we just, I think we should just solve it probably.
Okay. And are you allowed to use a calculator in this part of the course?
Yeah. Yeah.
Okay. So you just be very, very careful, especially when you're moving things around, to make sure that it makes sense. Like on the left here, you got 1.5x minus 9x, that's 9,000 minus 7.5x. And then it's your choice how you move things around. You don't have to move smaller to larger. Just got to make sure you don't lose any signs. Your answer has to be a number between 0 and 1,000 because that's the amount of tile you're using. So you want to look out for answers that don't make any sense. It also should be a whole number since you're dealing with tiles. You can cut
Hmm.
tiles in half, but um, there. So um, once you have X, you really are supposed to label which one that is. In this case, it goes with the 1.5 or $1.50 tile. And so Y is the perimeter or the edge tile, the $9 tile.
Hmm.
And so you have to find both. You have to say, okay, well, y is 1,000 minus x, which is 200. This is the $1.50 tile. This is the $9 tile. Sometimes they want you to write a sentence to finish it off to say like, you will use 800 square feet of the 150 tile, 200
Yeah.
square feet of like, it's up to you know what your teacher's expecting.
Yeah, we don't have to do that.
Okay. Sometimes on tests and quizzes, they have you set these up, but not solve them. Just
Mm-hmm.
so the time, to maybe be on the lookout for that, to not solve it. It would say in bold, like, do not solve if you're not supposed to. So if you're ready, we can look at 264. If you're still working through this one, let me know.
Yeah, I'm just working. I'm almost done. Okay, I don't think I got the right answer, but I also don't think I set it up correctly. I got 39 point something for T.
Okay, so
And
you're
we
using your,
got,
that's fine.
so I set it up like 150. Oh, I see what I did. But I set it up 150 T instead of 1.5
Okay.
X.
That would, yeah, that's definitely not good. It's the dollar, dollar times the amount, which,
So we keep the decimal in.
yeah, if they were all decimals, you might consider eliminating it.
Mm-hmm. Okay. Okay, that makes sense. I got the same thing.
All right, cool. So a new problem here. Um,
2.
so this is a percentage times amount. Do you want to try to set this up before I work it out, or do you want me to give you it's basically the same as the previous one, just instead of dollars, it's percent.
If you
Let's
could set it up
Sure.
first for this one.
So there he was he wants to invest it, and there are two types of investments he can make. So typically you go X plus Y equals 25,000. That's like your total equation.
Mm-hmm.
And then it's percentage times amount. So in this case, it's 4%, but you convert that to decimal. So he's getting a 4% return on the first investment plus a 9% in return on the second. And you want a 7.4% return on the total. And these are always percentage times amount plus percentage times amount, percentage times amount. It is another mixture problem. So there's always this total and then this mixture equation. Now, the mixture equation, you have to use this total equation because it's not y, it's the amount that's left over after you figure out what x is. So y always becomes, or the second variable always becomes the total minus the other variable. So this is one where once you write it out, you may actually want to multiply to eliminate the decimal. But because you have a calculator, I would tell you not to. I would say, no, decimals aren't great, but just if you have a calculator, go.
Mm-hmm.
is that okay? Is that a reasonable?
Yeah.
It really isn't more complicated than this. Percentage times amount equals percentage times amount. Or quantity, if you prefer quantity.
Mm-hmm.
So from here, we just be really careful multiplying in. I'll some numbers on the screen here. So this is 0.04x plus 2,250 minus 0.09x equals. And they generally make these work out nice. So if you see numbers that don't appear to be nice, check your calculations.
Yeah.
By now, you should be very comfortable kind of manipulating these equations.
Mm-hmm.
So x equals 8,000. The other thing you'll start to notice the more you do these problems is that the wherever the mixture is, like if the mixture number 7.4 is closer to the 9, that means you're going to have more of the 9 and less of the other one. So whichever number that gravitates towards, uh, that's kind of your check. Like, is it reasonable? So y in this case is 25,000 minus x, which is 17,000, and that's consistent with what I just said, which is it should be more at the first one is the 4%. This is at the 9%. Well, because we're trying to get closer to 7.4%, we need more of this percentage.
Mm-hmm.
Right, 266 is somewhat the same. It's not exactly, though, a mixture problem. Let me know when you're ready for us to go through this one.
Sorry. Yeah. I'm just.
I know I
I
don't
didn't
leave
get
enough
a.
time to get caught up.
I didn't get a pretty answer on the last one, so I kind of had to go back and.
Okay. Yeah, check your combining like terms. Let me scroll up here. It does work out nicely.
Mm-hmm. Did Did you subtract 0.04x from?
Yeah.
Oh,
Yeah.
because I'm writing. I was writing just 0.9. Okay, wait. So minus 0.09. You got negative 0.05, right? I see what you did. Okay. Negative 0.05 equals. Did you divide just by? Yeah, you divide by. How did you get
What?
negative 400?
You subtract the 2250 from both sides.
22. Oh,
Yeah, it sounds like you're gonna have to make sure you get a nice answer when you're working through these, or you're gonna
yeah,
have to redo them.
messing up my numbers.
They're not like difficult. They're just they've got a lot of
No, yeah,
places where you can
I'm
make
just like forgetting
mistakes.
to add like zeros and stuff. 2250. Okay, on to the next one.
So this next problem here, like I said, it's not really a mixture problem. Let me pull it up on the screen. It's not even up there. It's it looks like it, but it ends up they're giving you like sorry about that. They're giving you X and Y. They're telling you like Dominic pays 7% interest on his $15,000 college loan and 12% interest on his $11,000 loan. So that percent times amount plus percent times amount we already have. It's 0.07 times 15,000 plus 0.12 times 11,000 equals.
Mhm.
Now, what we don't have is the percentage here, which will be the variable, but we know the total amount is 26,000 like that. So the variable here in this case, and you can switch to another letter if you want. I would call it like R. But you can see it's actually not that complicated. You get this number here on the left, whatever that is, we'll get that in a moment, equals R times 26,000, and then you just divide by 26,000. So we have to just multiply these, add them up.
Okay.
This one does not work out nicely, meaning it's not a good a number as I thought it would be. Does one sit around? Yeah, it does say. So it says to round here, ends up being
Mm.
0.091 or 9.1%.
Yeah.
Right. So yeah, I did have some adjustments to my schedule. So if you do want us to carry on with the lesson, we can do that, or we can stop right here, Hector. It's totally up to you.
That's all right. I got a better understanding of this now.
Excellent, excellent. Okay, so I'm gonna go ahead and stop the lesson right here.